So, ladies and gentlemen, good evening, and to our friends on the opposite side of the globe, welcome and a very good morning to you. I'm Muhammad Subhi, a senior petroleum engineering student at the University of Mosul and an officer at the SPE Erbil Section, along with my colleague Saeed Abdulaziz, the membership chairperson at the SPE Erbil Section. And we are delighted to welcome you to this webinar. Please allow me to introduce the webinar series of which today's event is about. This series explores a critical topic in the oil and gas industry by well-known engineers and industry experts. It's organized by the SPE Erbil Section on October we will hosting the Professor Shohab Mohagig also to talk about AI-based proxy modeling and more exciting webinars to be announced in the near future. Our speaker for today is Mr. Atheer Al-Attar, an oil and gas professional, a data scientist, and Fulbright scholar with a great portfolio of SPE papers. He holds a bachelor's degree from the University of Mosul in mechanical engineering, and he further expanded his expertise by earning 2 master's degree in data analytics and petroleum engineering. He also worked with the industry leaders like BB as a workover and well integrity engineer, and with Baker he used as a geoscientist. Also, he worked with DAS International for oilfield services as a petroleum engineer, and currently working with the Spotfire as lead data scientist. Without further ado, I extend warm welcome to Mr. Atheer and express our gratitude for accepting our invitation. So the virtual stage is now yours, Mr. Atheer.
Thanks, Mohammed. Thanks, everyone, for having me. My name is Atheer, and then I'm a data scientist at Spotfire. I mainly deal with oil and gas customers in different use cases, ranging from upstream, midstream, to downstream. So in today's, Mohammed, can I start presenting?
Yes.
I think I can. Okay. Let me. Okay. Can you all see my screen? Should be able to.
Yeah, it's very clear.
Okay. Yeah. So in today's presentation, I wanted to kind of like share with you how the oil and gas customers do their machine learning and artificial intelligence tasks, and how do they use our products plus open source products. So now this might seem like a kind of let's say a product promotion, but the reason why I'm why I would like to tell you about our product is because we have a very large footprint in oil and gas. And then I've been using Spotfire before I joined TIPCO. So I was working with a company called Enterprise Products. It's a midstream company. And then we use Spotfire. And then now every client or like every oil and gas company I meet here, I mean, especially in the US, the main players, they use Spotfire. So that's why whenever I meet new graduates or like, let's say, young professionals like you are, or even students, share with them how do other clients are using the product, or like how do people are machine learning and use cases. Now, talking about the machine learning and AI use cases, or like the data science in general, I think the tool selection is very important, because that will determine how much time you will spend to get your data ready for modeling and analysis, and will also determine how easy for other people to reproduce what you did, and then like to For example, you are modeling a drilling optimization use case, and then you come up with the final model. It's good. You're happy with it. How easy for me to reproduce what you have done and then get the same results? I guess that's determined to a very large extent by the tool that you're going to use. Okay, so what is Spotfire? If has like anyone of you used Spotfire or like heard about Spotfire? You can use the chat, and then we'll see. Okay, seems no one is familiar with Spotfire. Okay, let me okay, so Spotfire basically it's a data science AI and ML platform, and then what the philosophy behind the product is, we're trying to bring everything all in the same place. So you connect to your data sources, you cleanse the data sources, and then by the way, the data preparation and then data cleansing takes up to 70% of your time when you're working on a data science product. And then after you cleanse your data, you start with the let's say, or they call it the feature engineering, like to choose your variables. What is the variable that you think will be like most important to your use case? And then you start your modeling, and then visualization, model evaluation, and then you communicate your results. So in Spotfire, we're trying to like bring all of these tasks all together in one place. So this is the main interface of the program. You can bring your data sources here, and then you can connect to multiple data sources, whether your data source is in a static file, or it's coming from Amazon, or it's in a database. It doesn't matter. You can connect to like almost any data sources that you have. We have a very large library of visualizations, so you can access almost like 60 visualizations here to visualize your data. You can, okay, so this is an application opener. We'll talk about it in a few minutes. You can write your Python and R scripts here to extend your modeling tasks and data cleansing tasks. And then you can also let me see. And you can also like connect to other systems. Yeah, go ahead.
Sorry to interrupt you, but you couldn't see anything in your about your presentation.
You cannot see? Okay, wait.
Yes.
Yeah, you better.
The presentation is very clear, I think.
Okay, no, because I'm presenting the application. So yeah, please let me know.
Yeah.
Okay, I'm sorry for that. Yeah, thank you for notifying me. Let me. Yeah, because I thought I'm talking about the. Let me. Okay, entire screen. Let me. Yeah. Okay. So can you see the? You should be able to see the Spotfire.
Yeah, no, I can't.
Okay, yeah, thank you for that. Sorry, guys. Okay, so yeah, as I said before, this is the main interface of the program, and then what we're trying to do here is we're trying to like bring all your tasks in one place. For example, nowadays, if you're trying to, let's say, do like a data science project, you might start, let's say, working on your data in Python, doing the data cleansing part in Python, and then doing the modeling in scikit-learn, and then you might choose to visualize results using any of the like visualization programs, for example, or Power BI or Tableau or like whatever. What we're trying to do here in Spotfire, like to give you a platform that you can do everything in one place. So I don't want to talk a lot about the let's say the theoretical things, but like here are, for example, the visualizations that you can do in Spotfire. Here is the system architecture that you can implement in Spotfire. So a Spotfire can be here, and then you can connect to all systems. For example, if you're doing streaming, if you have, for example, data coming from a Derwent rig streaming, you can connect to like other elements of the system. If you have, let's say, data stored in databases, you can connect to it. If you have big data systems, for example, like Spark or cloud systems, you can connect to it. If you have, they call it master data management, for example, access control for people, you can also connect to that. Okay, let me jump into the use cases that we have in oil and gas, and what we in oil and gas. This is a use case. It's about optimizing the well placement. So let's say that you have a reservoir, and then you have already drilled wells here. So these are, let's say, the drilled wells, and then they're all, yeah, most of them are horizontal trajectories. Well, and then you're trying to find, let's say, where you should place your next well. So what we did is we brought the current trajectories in Spotfire, and when you select, let's say, any area of your reservoir or of your leased area, you will see the wells that you have selected. You can also see the formation breakdown here across the well bars. And now moving on, so this tab is a representation for your well bars, represented on the reservoir area, broken down by colors to identify the formation. And moving on to the next tab, and here we can lay over the TOC map or the total organic content map over the reservoir. Why we are doing this? Because we want to place a new well, and then we want to make sure that we place a well in an area that has a lot of hydrocarbons, or let's say relatively more hydrocarbon than other areas of choice. And then this is a 3D representation for the TOC map. In Spotfire, you can also add a lot of controls. So in here, we use a method called smoothing, or sometimes the geostatistics people they called it kriging. It's basically you have a couple of points here, and then you kind of like try to approximate to generate a heat map that represents your variable. And then our variable here is the total organic carbon, hydrocarbon. And then you can also, what I'm trying to say is, like, you can also use this control to kind of control the way you're smoothing your variables. So you can see, like, the way the more that kind of like you drag the variable to the right, that will affect how the heat map is calculated, and it will be like more smooth. And then maybe if you drag it to the left, it will be I guess kind of like ragged and then more detailed, and then less smooth. And then this function was done using R. So if you'd like to like write R functions or Python, and simply you won't lose that using Spotfire. Now moving on, so now we know like we have well locations, we have our total hydrocarbon map, Now we're trying to do is can like say select the area, or select an area on the reservoir, and then the function that we wrote here, it will calculate the remaining drainage area. So what does that mean? So around every well you have a drainage area. What you're trying to do is you're trying to make the next well bore, it's kind of like outside this drainage area. The way that we use that is we brought also a Python data function to help with that. So you can see here these areas with the, let's say, the kind of like strong pink. These are the areas that you can drill in. And then these kind of like black lines, these are the actual well bores along with their drainage area. And then you can also control kind of like how big you want the drainage area. For example, maybe if you have a high permeability formation, you can kind of like increase this this variable. It depends on like the use case. But what I'm trying to say here is now using the data, using the platform that you have, you are able to kind of identify at least the potential areas where you can place your next well bore. Now, as a result, you will have a map with all the let's say the drillable areas. You can also like break down this map, or kind of like filter this map to be in a specific total hydrocarbon area. So, for example, you see this the TOC map that we laid over at the first tab. So it's laid over here, and you can see these are all drillable areas. But for example, if we want the if we want the dashboard, or like if we want this visualization to show only the areas that, let's say, more than 0.6, so we can basically just move the controller here and then the map here. Now, having this piece of information will help the let's say teams, the decision makers to take the decision, or look to make a data decision. And that's what we're trying to do when we use the data science, ML, AI techniques, and in oil and gas. It's like, just keep in mind, when you want to use an AI and ML, what is your what is the business benefit that will come back from your approach? I mean, don't just use the let's say the ML or AI techniques just because like they're kind of like cool, or they'll look good on your resume or something. No. With that, make sure like you stay focused like during the data science process, because the data science process is a long process. You start by collecting data. The data most likely will be unclean, and you need to clean that. You need to choose your variables. You need to do a lot of modeling along the way. But like along this journey, make sure that you don't lose the focus on the business need. Why you are doing this? Who's going to be the end user of that? How this work can assist in the decision making. Yeah, any questions? Feel free to ask any question. You can unmute yourself, ask your question. You can type your questions however you are comfortable with. Okay. Let me also present another use case. Yeah, guys, make sure you ask questions. Don't make me feel like I'm talking alone here. Okay, this is another use case that we worked on with another company called Revit. And what we're trying to do here, we're trying to kind of like replicate the completion process. This is unconventional completion. So, okay, this is unconventional completion process. So what we're trying to do here, this is a hydrofracturing. So what we're trying to do here, we're trying to monitor the well pad, everything like in the well pad, from the, let's say, from the moment of the crew arrival to the well pad to the moment of, let's say, finishing the fracking, the plug setting, and the let's say the final completion. So this is also done in Spotfire, and the reason why I'm showing you this, I'm trying to show you how different people approach their problem using one product, but using like different ways. So this is an overview for like your current operations. You can see your like your crews here. You can see like which well is online, how much fuel consumption you're doing, and also some KPIs here just to see that how you're doing. Are you doing well? Are you kind of like over consuming some of your fuel and materials? And this is a comparison here. So this is kind of like an overview page. This is a live plot from the well pad, so you can see it's kind of like moving here to show you the most recent values. We also used classification algorithms here to detect which well is active now, and then also we used some regression analysis, kind of like predict or detect the current activity. So by looking at the pressure, by looking at the flow rate, we can tell, okay, they're fracturing now, or like, okay, they're preparing the pad now. And then you can see like as the time goes. So this is one case of using machine learning. I would like to show you the other one. This is also.
Wait, Atheer.
Yep.
So you said you used classification on the flow and the pressure variables to
Yes.
classify the status of what they're doing.
Yes. Yeah.
Okay.
Yeah.
So you just used a bunch of time series data, or was it?
It is a time series data. So we have, it's kind of like it's a supervised. It's not clustering. It's a classification. So it's a supervised, and then it's more of like a rule based. So so during the process of creating this dashboard, we had continuous meeting with the engineering crews and then field crews. So there was like communication back and forth, and then according like we kind of like involve that domain knowledge to our classification script. And it's like the whole data is time series, and then you can see now the active well switched to by B5H. It was 3H. So we're looking at the, let's say, multiple variables. We're looking at the pressure. We're looking at the flow rate. We're looking at the slurry rate, the proppant consumption.
But it was a supervised model.
For the classification, yes, it was a supervised model. And then we implemented that using Python inside Spotfire. This is the coil tubing.
Just one more question on the other one.
Yeah, go ahead.
Looks like it's pretty fast, right? Looks like it's classifying. Is it classifying the real time?
Yeah, it does that real time. Yeah. Yeah, it does that as the data comes. But this is like this data stream. It's basically it's a simulated stream from one of our servers. It's not, let's say, this is not currently out in the field right now. It's coming from field data, but we're just like looping that in one of our Kafka servers.
So you can implement like an online online inference on the dashboard.
Mhm.
You do inference real time just by having like the auto refresh selected on the data function.
Yeah, and then you don't need like you don't need to set up any auto refresh. The auto refresh will come from your streaming server. So like how much you set up the auto refresh on your, let's say, upstream server,
Okay.
Spotfire will see that.
Okay.
Good question. Okay, so this is yeah, this is also just a visualization for the cold tubing activity, and then I also use we call it visualization mods, which is basically like kind of non-standard visualizations. What I'm trying to do here is I'm trying to visualize the well bore, so you can see this is a depth track for the well bore and all the activities of the well bore. So whenever like you have a charge or like a perforation charge fired, you will get, let's say, a label that shows you like when this charge was fired and at which depth. And then whenever like have a plug set, you can see that also. Okay, pad metrics. So in here, we're trying to analyze the time and the equipment usage for the well pad. It's called critical time analysis. Okay, and yeah, we're basically looking at all the 3 wells, and then we're trying to identify if there is like any time slot that we don't have let's say we don't have any usage for the equipment. So like this is like kind of a very ideal operation. Most likely you won't see such performance in real time. You will most likely see some here that identifies an unproductive time. And then we're also looking at the propane concentration consumption here across all the stages, across all the wells. Just to give you an idea how you perform across all the wells, across all the stages. It's kind of like identify any anomalous behavior. So for example, you can see here in stage 13, you have kind of like an anomalous consumption for the friction reducer. This is like one of the materials that they use at the fracturing. So that might signify like something at this depth. You can go back and you can see like this happens like across all the wells. So you may want to, let's say, go back and then kind of like review or like correlate that with other variables like the slur rate, the flow rate, and then see what causes this anomalous behavior.
Hey, what's the difference between 3H, 4H, and 5H?
These are all different wells. So they're all in one pad, but it's different well bars.
Oh, okay, thank you.
Yeah. And then they call this in hydrofracturing they call this zipper operation. So it's kind of like a new technique for the hydrofracturing, where they kind of like make full utilization of the equipment. So they don't, like say, when they they frack on one equipment, they like say they frack on one well, and then they pump on the other well, and then they kind of like switch. And like the whole goal behind this is to kind of save some time and make full utilization of the. Okay, so this is one of the things that I was trying to also show you. And let me also bring another. Okay, so in here we are trying to cluster the pressure curve, or like the pressure treatment curve. So you can see here at each stage the pressure will go up, and when you start like fracturing, and then this is like the formation breakdown, and then you continue pumping, and then you shut in the pumps, and then you have like this fall down period, and then you start like a new stage, and you have this continuous signature across all the operation. What we're trying to do here, there is a variable called the instantaneous shut-in pressure, or sometimes they call it ISIP. Now, how to calculate that? There are a couple of research papers that show how to calculate that. But basically, if you want to calculate that after the let's say the pump shutdown, you will have a fall down period which is relatively short, and then you will have also like a hammer effect because you have a fluid inside the well, so that's why you have this oscillation. And then they kind of like read the shut-in pressure at this area. Now, what we're trying to do, I want to bring also on the dashboard.
Hey, here.
Yeah, go ahead.
Quick question on this one. So you're just doing clustering on the sequential time series data points for the pressure.
We're actually picking up a couple of variables, not only the pressure. We're looking at the slurry flow rate. We're looking at the clean flow rate. We're looking at the friction reducer consumption.
Is it also because it almost looks like it's doing like thresholds like at values, so it looks like pretty like straightforward values, but also it looks like it's like stringing together the sequence of
yeah, it looks like that, but this is unsupervised, so we're just coloring by the coloring here is coming from the clusters.
Okay. All right.
So we're kind of like it's not, let's say, you won't expect this to be like very kind of like ideal, because the data itself is not standardized. I mean, every stage is different from the other stage, but we try to kind of like provide the user with an automated way to detect the formation shut-in pressure. And you have the option here. So we did not like make this fully automated and it kind of like canceled out the let's say the domain expert. Any user can come here and then select any area that they think this is okay, this is the correct shut-in pressure, and they can basically save this as shut-in pressure. Or, for example, if we are looking at the formation breakdown pressure, they can basically come here and then maybe select this area, and they can basically just save this as a formation breakdown pressure.
Oh, cool. I actually like that because sometimes
yeah, and then
it's better to sometimes you can't get it to generalize across assets.
Oh no, I mean, yeah, generalizing is not like, it's not a good idea here, because you are in the I mean, the reservoir is not, let's say, homogeneous across the area, so generalizing things isn't a good idea. And then also ignoring the domain knowledge, it's not, let's say, it's not gonna give you a good outcome. I mean, you have to always like make use of the domain knowledge, make use of the field professional, you guys, to kind of like give input to the model.
So if you wanted to convert this to like a supervised model, you would have to get the SMEs to come in and label all of this time series data, put labels on of it.
Yeah, exactly. I've been looking into like other ways of detecting the formation breakdown pressure, maybe like more kind of academic ways, or like more industrially proved ways. So there was another research paper that looked at the issue of the formation breakdown pressure, and let me see if I can find it. Okay, Anyways, let me we can talk about it here. I don't want to waste your time. So basically, what I was trying to do is I was trying to kind of like isolate this fall down period. It's a pretty short period, so I was trying to kind of isolate that using like a mix of methods, unsupervised learning, like some rule-based, maybe like some user interaction to help me with the like with isolating this. So, and it was good overall. What I'm trying to do is to bring all these fall down periods and then kind of like try to isolate them here. The user also can control the process, so it's not, let's say, 100% automated. Yeah, they can enter the minimum fall down, the period, like how much we want to extend this, and then how much smoothing they want to do, and then after that, you will get another chart here, which is basically you can see like kind of like an aggregation of all these periods, like all these orange segments. Now you can refine this more by maybe selecting, because now we're looking at like all the operations, but maybe you can select like a small portion of your pressure data and you can get this collection of curves. Now with this collection, you can see there's a lot of kind of like bad data, outliers, everything. You can furthermore cut off the part that you are interested in. So after we cut the part off, Spotfire will do like some averaging to all of these curves and then kind of like produce one curve, and I will divide this curve into two segments. So this one, and then like this upper segment into segment, and then this lower segment. And you can also furthermore select what you want from this curve. So why I'm doing this? So there's this methodology in the industry. They call it the early departure method, and then the early departure method and the late departure method. So the researcher was looking at the pressure curve, and it was kind of like fitting two lines on the curve. There's this line, let's say at the first segment, and then whenever the curve will start departing from this line, it will read off, the researcher will read off the pressure on the y-axis, and it will like record that. And then there's the late departure method, which is also fitting another line on the second chart, on the second piece of the curve. And then whenever the curve will start departing from let's say the linearity, the pressure will be read by extending that line back to the y-axis and then like reading the pressure here. So this whole thing is kind of like, let's say, semi-automated. The user can interact, they can choose exactly what they want to include in their calculation, how much they want to include, and then how much they want to smooth the data, and it will, and the recalculation is done automatically as you like choose your parameters. And you can also like control like how smooth you want the curve to be, or how much, for example, a smoothing window you want to apply to your curve. So this is another example also of like using different techniques in ML, curve smoothing, maybe like some automation to kind of help you with your day-to-day tasks. Now, I mean, when I asked the field personnel, how do you do this? The answers were, okay, we kind of like look at the pressure curve and then do that manually, or like eyeball it, or like sometimes, oh, we have rule of thumb. We know like the formation pressure is around this value. So this can be like a very helpful tool to kind of save your time, validate your results, maybe like open maybe like more doors to do some research and analysis. So this is another use case, also in oil and gas. I would like to show you also a use case, ESPs, electrosubmersible pumps. So this dashboard also set up as a simulation from the field. So you have all your operators here, and then you have all your pumps or wells showing live. And then this is your curve across the time for and then you can see like some of the pumps, they have kind of like an alarming pressure profile that you need to review. Moving on, you can see an overview for the pump. For example, if you select one of the pumps here, you can see like, what's the status, what is the pressure trend, what is, let's say, the top trending pumps. So this is all done in Spotfire. You don't need to like bring any other product or something. You just need to like feed it from the field, your data stream, and then it will show you the visualizations. In here, you can see that you can adjust your pressure alarms. You can see you can adjust your motor alarms, and then you can see like your motor trend. You can see your pressure trend. This is not necessarily this is more of a kind of say surveillance other than a data science application. But why I'm showing you this, just to show you like an example of how you can use Spotfire for kind of live alarming, and then you can also feed this trend or like feed this lifetime series into kind of like an on the fly anomaly detection algorithm, or maybe like a pressure prediction or a maintenance prediction algorithm that will further tell you, for example, how long you left, like how much time you have left in this pump until you expect a breakdown. This is another example of using Weibull distribution, or basically it's using machine learning to perform your predictive maintenance. So the thing is, like with the predictive maintenance, is when you perform a maintenance on something too early, that will be very expensive, and then that will be unnecessary. And then when you perform a maintenance on a part too late, that might not be, let's say, very successful process, because it might be like already too late, and then you have many parts already broken. So there has to be like a sweet spot where you have to perform your predictive maintenance in order to save time and money and then your equipment, apparently. So what we're trying to do is we set up this dashboard, and then we use distribution called Weibull distribution. It's basically a distribution that tells you how much time you have left until a specific event will happen. After we input the equipment data, it's basically failure data, and then you can see them here. I'll come to this later on. So we input the equipment failure data, and then the dashboard will start producing this curve, and it will tell you basically need to perform your maintenance right here, and this is time. And you can change your variables here, and you can readjust as you go. And this is the Weibull analysis, and then you can see that the probability of a failure increases with time. And then there's like a specific point where the probability will start climbing. And then you can see also the instantaneous probability of failure, like the probability of having an instant failure, like goes down with time, because like as you have the equipment, let's say, operates for a long time, then the probability of having like an instant failure goes down. And this is root cause analysis. So the data was for ESP pumps. And then you can see, let's say, the main part that causes a lot of the breakdown is the road pump, basically. The failed component, you can see it here. And then this is like a breakdown of the failure data. So just to give you an idea, like what is most likely the part that will cause the failure in the pump. Okay, and then let me see. Okay, so this is the this will be the last example. Let me see if I have something to show here. Yeah, let me show. Yeah, let me show that example. This is not necessarily an oil and gas, but it's just like it could be related to. It could be related to pattern recognition, because we do a lot of similar process when we deal with seismic data. So we have these pictures of electronic parts, and in some of these pictures they have defect on it. The question was, or let's say the process was, before we implement this, the process was that we have a human in the middle that looks at the each part, or each piece of these electronic pieces, and it will detect, okay, this is a failure, and then this is not. And we tried to kind of like automate this process. So we collected a large amount of pictures, or not pictures, let's say, we collect a large amount of coordinates and color grading for these coordinates. And we produced patterns. So we clustered all these collected data into patterns. So starting from here, those were the patterns that we collected. And then moving on, we worked on transforming and then cleansing the data. And then we generated these patterns. Now, whenever you have a new pattern or picture, so we, like, after we collected the patterns, we trained a machine learning model to predict whether or not a specific piece of electronics is broken. So now, once you bring any of the pieces here, using this trained data and patterns, the model will be able to tell, okay, this is a failed piece, or this is not. And you can see here, using Spotfire, we were able to train multiple models, and then we can also evaluate the model here. Let me see. Let me go back. Okay. And then we can evaluate the model here, and then see how the model has performed. And you can also save multiple models here, so you can see like the prediction here and how did the model perform. And you can save multiple models, and then you can like go back and then like retrieve any model that you want. So if you, let's say, you can construct a new model from like a new variables, save it, go back to it. What I'm trying to communicate here, or to say, is having all of these features in one place can affect your ability and efficiency to perform data science tasks. Okay. Let me see. So this is the end of my presentation. Thank you so much for having me. I will share this page to the chat. These are all the oil and gas solutions that we worked on and the use cases. You can you can go over here. You can see lots of presentations, lots of use cases on how we and our clients are using machine learning, artificial intelligence, and oil and gas. There is also, I'm not sure if you have ever heard about it, we have a program called Dr. Spotfire. Dr. Spotfire is basically a monthly meeting. We meet with a lot of industry professionals, data scientists from like all over the industries. They just talk about their experience, their use cases. How do they use a specific product? How do they, let's say, solve a specific problem? So this is also could be a good resource for you. I would be happy to answer any question.
Thank you, Mr. Atheer, for this webinar. Anyone can unmute themselves and or write their question in the chat box.
Yeah, I can open the link. Thanks, Atheer. I really enjoyed it.
Hey, Jose. Oh, I just noticed that I'm sorry. I mean, I just noticed that you're here. I mean, I was responding to the questions, but I didn't. Yeah, I noticed that you're Jose. Yeah, Jose is a friend of mine, and he was we were working together in my previous employee.
Yeah. All right. It was a good presentation. Thanks, dear. Bye.
Yep. Sure. Bye.
Guys, thanks for having you in this meeting tonight, and thanks for Mr. Atheer for this amazing presentation. And please fill the your like the link, the forum link, attendance link, that is in the chat box, please.
All right, guys, if there are no other questions, I would like to drop off to catch up another meeting. Thank you for having me. I wish you best of luck. And then, you know, my LinkedIn profile, just look up my name. If you have any question, if you'd like to test Spotfire, I would be happy to help. Thanks again for having me, and you may have a good night.
Have a good night. Thank you so much for accepting the invitation.
Sure. Bye.
Good night, guys.